Hi folks, Peter Pan here. This is going to be a review of several sections on area, perimeter, circumference of similar figures, and arc length. Let's begin. Okay, if two polygons are similar, then the ratio of their sides equals their scale factor, and I just do SF or scale factor, plus I'm a Niners fan. So here's an example right here. You got a red polygon and a blue polygon right here. So this is going to be the ratio of their sides right here is just going to equal their scale factor. A over B would be equal to their scale factor right there. Okay, as long as these guys are similar, then the ratio of their sides equals the ratio of it equals their scale factor. Okay, so the ratio of their areas is your scale factor squared, and how I remember that is area is always square units, you guys. So it's going to be scale factor squared. Alrighty. Uh, so, so the area of the first polygon over the area of the second polygon is just a scale factor squared. You just square A over B. Okay, easy enough. Okay, so in this diagram coming up right here, find the indicated ratio. So here's the diagram right here. So it's probably going to ask for, the book says the ratio of the red to blue right here. So kind of looks sort of salmon color. It doesn't look red to me, but red to blue. So find the ratio of their perimeters. Okay, the ratio of their perimeters is also equal to their scale factors. So it's just going to equal, red to blue is going to be this side over this side. So 8 over 12, which reduces to 4 goes into 8 two times, 4 goes into 12 three times, so it reduces to 2/3. Okay, your book might write 2 with a colon in between at 3. This is also is read 2 to 3. Okay, is a ratio 2 to 3. This is also read 2 to 3. Okay, so let's find the ratio of their areas. Okay, the ratio of their areas, all we got to do is square that 2 to 3. So when I square 2, I get 4, and when I square 3, I get 9. So 4 to 9, or like this, 4 to 9. Okay, 4 ninths or 4 to 9. I prefer writing it as a fraction, but a lot of textbooks like writing it like that when they talk about ratios, but whatever. All right, so here's another one. Triangle PQR and XYZ are similar. The area of triangle PQR, remember area, the ratio of the areas is the scale factor squared, is 1200 feet squared, and the area of XYZ is 48 feet squared. So given that side PQ equals 50 feet, find side XY. Okay, well that's easy, you guys. Remember the ratio of the areas, they gave us those numbers, is 1200 over 48. Now what a nice coincidence that that reduces to 25 to 1. Those are perfect squares. Remember, this is the ratio of the area, which is the scale factor squared. So what I'm going to do is square root that, and that's going to get me what the scale factor is. The scale factor is 5 to 1. So if the scale factor is 5 to 1, I can set it up equal to the ratio of their sides. So then that means 5 to 1 equals this PQ over XY. Okay, notice PQR goes on top because the bigger number was on top, and that stood for PQR right here. Okay, so PQ goes on top. You have to be consistent like that. So 5 over 1 is going to equal, they gave me the 50 over that, and then you can cross multiply. Pretend like that's an X. 5X equals 50. So we find out that missing side length is 10. Okay, so what we had to do is square root the ratio of the areas to find the scale factor, and then that was the goal right there, is to set that equal to my sides, my ratio of my sides, and then cross multiply. Okay, change directions a little bit. Circles. The area of a circle is pi r squared. The circumference of a circle, there's two things. It depends on if they give you the radius, then it's 2 pi r. If they give you the diameter, it's just pi times d. Okay, sectors of circles that have central angle in, the area is, you just use the circle area. A sector is like a little piece of pie or a piece of pizza, you guys, with that little piece being in the middle. So you use your area formula and then just multiply it by n over 360. It's the fraction of the whole circle. Okay, so n over 360 times pi r squared, and then circumference is going to be n over 360 times your circumference formula. Okay, so the arc length right there would be that. Let's try a couple examples of this, you guys. So find the length of each red arc. Okay, so right there, I'm going to find the length of that red arc right there. So this is a length is, when it's talking about length of an arc, that's part of the whole circumference, the circumference that goes all the way around. So I'm going to use my 2 pi r formula. There's n right there, 60. There's the radius, 8. So I'm going to use this formula, 60 over 360 times 2 times pi, and then the radius is 8. So here we go. Okay, so right there, and then I noticed 60 and 360, the zeros cancel, you guys. You can cancel these zeros right here. And let's see, do I have it? Yeah. So those zeros just cancel when they end in zeros. And then 6 over 36 reduces to 1/6, you guys. And then you can cancel this 6 with either the 2 or with the 8. I forgot what I did. Let's see. I canceled it with that 2. And then so I'm left with the 8 pi on top over that blue 3. So the answer is 8 pi over 3. Okay, books like to change it to decimals, so they did 8 times 3.14 and then divided that by 3, and that's where they got that 8.33. And it's in centimeters because it's just distance, you guys. So you're dealing with, whenever it's area, then it would be centimeters squared. Okay, and we're going to do that next. Okay, let's find the same thing. Find the length of that red arc right there. Okay, the length that's a part of the circumference right there. So it's going to be, there's n, 120 over 360 times 2 times pi times the radius 11. Okay, here we go. All right, okay, again, these zeros cancel, and then 12 and 36 reduce to 1/3, and then nothing else cancels, looks like, so I'm going to go ahead and multiply 11 times 2 on top to get 22 pi over that 3, and your book will probably change it to 22 times 3.14 and then divide that by 3. Okay, and again, centimeters. Always put your units too, you guys. Let's try and be consistent and be good with putting our units. All right, so this says find the areas of those figures, of those sectors in the last section, section F right there. So here's that picture again for number 1. Okay, now we're just going to find the area. We're going to find this little area of this piece of pie right there. So pretend like we're just looking at that, the area. Okay, area is pi r squared for circles. So we're going to use that n over 360 action again. So there it is, n over 360, and then the zeros can cancel. And then 8 squared is 64, and then I reduced that. And then the only thing that goes into 6 and 64 is 2, you guys. So 2 goes into 6 3 times, and 2 goes into 64 2 times. So you're left with 32 pi. So 32 pi over 3 centimeters squared. And I forgot to convert that to a decimal, you guys, but you just do 32 times 3.14 divided by 3, and whatever that is, it's area, so we're finding area. Area is always in square units right there. Okay, one more. Let's finish that last one up. You got this guy right here. Okay, so this time n is 120, so 120 over 360 times pi r squared, pi times 11 squared. Okay. Okay, again, I'm going to go ahead and cancel these zeros. These zeros cancel, so I'm left with 12 over 36, which is 1/3. Okay, so 1/3 and 11 squared is 121. And let's see, no, 3 doesn't go into 121. I was adding 1 plus 2 plus 1 in my head, which is 4, and 3 doesn't go into that. So I get 121 pi over 3 centimeters squared.